What's up everybody? This is the second and last part in the video series about my February scrap haul. Today we're going to be taking a look at all the motherboards that didn't make it last time. Motherboards that needed repairs before being able to use them. And there were quite a few of those. So what are we waiting for? Let's get started. The first thing we have today is the meme board, the K7S41GX number 2. Before we can do anything with this board, we have to take care of this little capacitor that's just hanging in there. Since ASRock is an ASUS brand, you should be aware that the polarity markings on the capacitors are reversed from how they'd normally be on the silkscreen. Well, the board works, but this is kinda purple, wouldn't you say? Doesn't seem to be a contact problem on the VGA, so let's take a look on the oscilloscope on the RGB lines. I first traced the RGB lines to this resistor network. And here's R. And here's G. And here's B. And as you can see, the green signal is missing. Well, it goes to the other side of the board, and there's your problem. There's a ripped off 0-ohm resistor here. If my theory is correct, if I bridge those two pads, I'll get the full color back. Ah, well, we can deal with that. There, like new. Here's a socket you'll rarely see on this channel. It's a socket 754 motherboard, an ASUS K8N. This board hosts an Enforce 3250 chipset. This board is generally in a really good condition, but it's plagued with bad capacitors. Normally, if you find bad capacitors on a ASUS board of the time, they would be bad series with manufacturing defects of known good manufacturers, such as Nichicon HN and HM or Chemicon KZG, but these are actually bad brand capacitors. They're made by L-Tech and they're all 1000 microfarad 6.3 volt capacitors. So let's just replace all of them. Cue the montage. Well, that's that. It's time to test it. And another job well done. The board's completely fine. Boot it into DOS, did a test run of Doom for no reason at all, and file it under S for success. Not to be confused with S for sucks ass. Something that definitely doesn't suck ass is this Enforce 2 motherboard from MSI. This is an MSI K7N2GM, a micro ATX socket 462 motherboard. The problem with this board is a couple of bad capacitors, no biggie, some that are bulging and some that have been dented from the scrap life. So it's time for another quick montage. Well, it's time for a test, except I can't turn the board on using the power switch. Abusing the power on mechanism of the ATX power connector, the board starts up but it doesn't come out of reset. Something is wrong here. To be fair, I did forget to put this capacitor, but would that really cause this problem? George doesn't seem convinced, at least.
Just wasted a capacitor, man.
Wait, what?
Yeah, it's fucked.
What's fucked?
That board.
Why?
Deado. You said it. It doesn't turn on.
Ha!
Oh. Okay. I was wrong.
The most important capacitor.
The most important capacitor, really. Holy crap.
That could be the 3.3 standby regulator. Doesn't start because the bulk capacity is missing.
Yeah, it could be, yes.
Well, next up we have this ASRock K7S8X. It's basically the full ATX version of the K7S41GX that we've been memeing about before. And this one has a bit of an AGP problem. The slot has been, well, not treated too kindly. A few pins jumped out of their mountings, and the whole armature is just a little bit worse for wear. Much more important than that, there's a bunch of capacitors here just hanging on by a thread. Let's get those replaced. Montage yada yada. Well, for now we can say the board does work with a PCI graphics card, but really should see what we can do with that AGP slot. Being an expert in using my fingers delicately, and with brute force, I decided to use both. First, gently guiding the pins back into their sockets. And then just yanking the whole thing back into shape. Oh, this pin is actually bent and won't budge. Time for more finesse. It is time to put our tough love to the test. Let's insert a graphics card and see. Wow, it works! Well done, myself.
Patch, 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 patchy.
Getting deja vu over here. Actually, the second K7 S8X is in much better condition than the first one. There's only one problem. It doesn't post. Post and beep codes seem to indicate a memory problem, but the same memory just worked on the other board, as did the CPU and all the rest. Since this uses DDR, my first instinct was to check the VREF. The DDR1 voltage reference is supposed to be 1.25 volt, and that was missing. So I already thought I was in a pretty good track, but it turns out it's derived from the DDR voltage, which is 2.5, and that wasn't there either. I'm gonna spare you the details of troubleshooting. It was essentially just following the signals around. It turns out there was only one possible suspect, which was a transistor which was used in the regulation for that voltage. It's a 2SB1202. The voltages on this transistor were different on the working board than on this one, so I decided to just replace it. Oh whoops, I messed that one up. That is my fault, I apologize. To the family of ASRock, that is my bad. Since I already own a scrap K7 S8X, I just swapped it over. Hey! Look at that, man!
Nice.
Out of respect for the viewer's sanity and mental health, I shall not play another patchy clip just to congratulate myself for a job well done. Well, here we have another, well, objectively pretty terrible board. This is an ECS Elite Group K7VZA, and it's the cheapest, crappiest KT133 board you could get. These things are riddled with G-locks on capacitors, and they're all bulging over here. So really, objectively, there's no reason to fix this. There's only one slight problem. I kind of have an affection for this board, because my high school used to have computers with it, right before they were replaced with P4s around 2005. This one is not in too great of a shape. I mentioned the capacitors, the first DRAM slot is busted, and the AGP slot as well. But I really want to fix this, so let's tackle one thing at a time. Capacitor montage. Here's the first test and it gives me a RAM beep. That's not surprising considering I used the busted SDRAM slot. But even trying the good slots, it still gave me the same beep. Nope. Nope. There's something fishy going on here as well. Ah, I found the problem. There's the problem. Somebody slipped with a screwdriver here or something, rammed right into this motherboard. So let's fix it. First of all, gotta remove that glued-on heatsink. Well, there's two ripped off SMD components. The capacitor we don't really care about, but the resistor may be crucial. Let's worry about that later. Look at all these dents in the board, like there's been a lot of slippage with the screwdriver here. Was the scrapper too stupid perhaps to get the heatsink off and tried like 12 times, denting the board in a different spot every time? Let's apply the grinding tool and see if there's copper left below there. Okay, so those traces are all okay. Those right there most definitely are not. I took a look at all KT133 boards that I have. And literally all of them have a 22 ohm resistor roughly in the same vicinity as this one. So I took a gamble and put one there. Anyway, let's work on those traces. I removed the solder mask with the grinding tool, tinned the leftover copper, and then I bridged the gaps using some really thin wire with a diameter of 0.15 millimeters. Before we fix that up properly, let's give it a quick test. And would you look at that, awesome! The board posts and it seems to work absolutely fine. But remember, we still got a bunch of problems left. Let's get that SD-RAM slot out of there. I can't stand looking at it. This slot is brought to you by a dead Asus A7V because I've had 4 of those and all 4 of them were dead. I don't know what the hell is going on with those, but they're good parts donors. Got that all solder in there, let's test it. Yes, it works. Thank you. Well, I was about to do something about that AGP slot, but I couldn't get the pins back in the housing like I did with the other one. And while trying to do that, the bottom half of the slot just broke off. So I have to replace that as well. Montage! And the AGP slot works. That's pretty epic, I'm pretty happy with that. The only things left to do with this board now is cleaning everything up and then covering all the exposed bits and all the repaired stuff with UV curable solder mask. And of course we have to put on that Elite Group heatsink again. Done! Alright, prepare for a mouthful. This is the Foxconn 945 G7MD-8KS2H. It's an LGA775 motherboard with a 945G chipset. It has bad caps. Let's fix it. Well, before we test it, we should probably put a heatsink on that north bridge because it does get quite warm. Well, the post kept freezing and I don't know what code 45 means. After I moved the RAM to the last slot though, it ended up working. Through trial and error I did figure it out. As it turns out, one of the RAM channels was dead. The right 2 slots worked while the left 2 slots didn't. That just screams signaling issue to me. And my hunch proved to be correct. I found this area on the board that seemed to have the same kind of dent damage as the others. Why are scrappers always so violent when pulling the coolers off? I don't understand. In any case, armed with a grinding tool, I got to work and soon uncovered that this trace indeed had an interruption. Our gut feeling was proven correct once again. This was indeed the culprit and the board does work perfectly now. All that's left to do is cover it all up with some solder mask and be done with it. The last board for the day is the MSI MS5169. This is a Super Socket 7 motherboard with the venerable ALI Aladdin 5 chipset. In my opinion, the best chipset for Super Socket 7. Also found on legendary boards such as the Gigabyte GA5AX and the Asus P5A. Since I own those 2 boards, the trifecta would truly be achieved if I can get this board to work. This board has a pretty bad case of bad caps, but that's not all that's wrong with it. On the other side we can see a bunch of corroded traces. that look from the outside as if they'd been interrupted by the corrosion. It's strange, this board was made well after the Varta plague, but the culprit did turn out to be the great-grandson of those. I've never seen this before, but this CR2032 coin cell battery has leaked and corroded the traces below it. Now that is truly perplexing. I have exposed, verified and retinned all of those traces and found absolutely none of them to be bad. That's a huge relief, lucky me. And at this point in the video, you're already used to replacing capacitors, so I'm not even gonna play any montage music. As a side note, I've also replaced the coin cell holder because of the corrosion. I got out my trusty AMD K62 Plus 550, jumpered the board for that and hoped for the best. Yeah, the board works. However, there's a slight problem. The BIOS doesn't recognize the CPU properly. Now that's weird. Now, anytime I encounter a problem like this, I would just expect the BIOS update to fix it. The only problem is the BIOSes that are newer than the one I'm already running are specified to work on PCB revision 4.0 only. And here's where it gets complicated. I have the version 2.1 of this motherboard, and the K6plus.com compatibility list has the following note on it. It says that the 2.1 version of the board doesn't work with the latest BIOSes because the BIOS ROM chip size is too small. Well, that's curious because it turns out the BIOS chip on my board is exactly the size needed for those later BIOSes, and they're the exact same size as the old BIOSes. What the hell is going on here? I really couldn't make sense of it all, so I just decided to YOLO it and flash the BIOS on there anyway. And wouldn't you know it, the BIOS works just fine. I don't know why it wouldn't, and I don't know why that notice is on there. I'm just gonna pretend that everything's fine, be happy in my little bubble, and enjoy a working motherboard. As per usual, cover all the exposed traces with some UV solder mask, and then we're finally done with everything. Now that's what I call a repair marathon. Thank you very much for your attention. I'll see you in the next scrap load. Bye bye.